an independent editorial analysis of East Asia military developments and regional security dynamics.
The delivery of 50 transporter erector launchers for the 600-millimeter large caliber multiple launch rocket system, designated as KN-25, represents a deliberate transition. It is a move from technological validation to the establishment of a standardized, mass-produced force structure. This development suggests a significant shift in the strategic calculus of Pyongyang. It moves beyond the symbolic value of occasional tests toward the creation of a persistent, high-volume strike capacity. From a systems perspective, the sheer scale of this deployment indicates that previous industrial bottlenecks may have been mitigated. The challenges associated with high-precision guidance and large-scale vehicle assembly appear to have been addressed, potentially through the integration of foreign dual-use technologies or a significant reallocation of internal resources toward the second economy. The claim of integrating artificial intelligence into the fire control and guidance systems introduces a complex layer of ambiguity. While the term is often used broadly in political rhetoric, in a technical sense, it likely refers to the automation of trajectory correction. This would be aimed at overcoming the limitations of traditional inertial navigation. The operational significance of the 600-millimeter system lies in its hybrid nature. It effectively blurs the distinction between tactical artillery and short-range ballistic missiles. By deploying these systems in such high numbers, the state is complicating the defensive architecture of regional adversaries. Traditional missile defense systems are designed to intercept a limited number of high-value targets. They now face a saturation challenge when confronted with a salvo of dozens of 600-millimeter projectiles. This introduces a significant trade-off for defending forces. The cost per interceptor far exceeds the cost of a single KN-25 rocket. Furthermore, the range of approximately 400 kilometers places critical command centers and logistics hubs within a continuous threat envelope. It effectively nullifies the depth previously afforded by geography. The emphasis on mass production suggests a move toward a doctrine of overwhelming saturation. The objective appears to be the degradation of the opponent's decision-making window by forcing an immediate response to a multi-axis strike. Integrating sophisticated guidance into a system of this caliber highlights a persistent constraint in the defense industrial base. The requirement for precision at extended ranges demands high-quality microelectronics and sensors. These are components that remain under stringent international sanctions. The successful rollout of 50 launchers implies a stable procurement network or a significant advancement in domestic manufacturing. However, the reliance on such technology introduces a systemic vulnerability. If the software and hardware integration is as pervasive as claimed, the entire strike complex becomes more susceptible to cyber interference and electronic warfare. This creates a strategic tension between high-tech precision and the necessity of maintaining a rugged, dependable arsenal. The decision to prioritize complexity suggests an organizational confidence in protecting these assets from non-kinetic neutralization. This industrial scaling also points toward a significant evolution in the heavy machinery sector. The ability to manufacture dozens of specialized 8x8 or 10x10 chassis simultaneously suggests a mature supply chain. It indicates coordination between metallurgy, hydraulics, and automotive assembly under extreme isolation. From a budgetary standpoint, the investment required for such a fleet is immense. it likely consumes a substantial portion of national defense expenditure. This reallocation of capital signifies that the 600mm platform is now a primary pillar of conventional deterrence. The organizational move to consolidate these systems into dedicated mobile brigades reinforces the idea that they are intended to operate as a coherent, networked force. The timing of this force expansion serves as a structural indicator of defense priorities for the 2026 to 2030 period. This phase appears to be defined by the hardening of the second strike capability. By transitioning these systems to frontline units, the leadership is delegating a certain level of operational authority. This requires a highly disciplined command and control framework to prevent accidental escalation. It highlights a critical challenge: the balance between centralized political control and decentralized flexibility. The integration of AI might be viewed as a tool to bridge this gap. It could provide automated safeguards or optimized firing sequences that align with pre-approved objectives. Such a system could theoretically act as a digital gatekeeper. It would ensure that the release of munitions remains strictly within the parameters defined by the central leadership. From a geopolitical standpoint, the expansion of the 600mm fleet cannot be viewed in isolation from cooperation with Moscow. The deployment of personnel to external conflict zones has likely provided a wealth of telemetry and performance data. This feedback loop probably informs the iterative upgrades seen in the KN-25 series. Specifically, it may assist in refining guidance algorithms to evade modern air defenses. However, this dependence on external conflict data introduces a long-term strategic dependency. The sustainability of this program is tied to the stability of these bilateral relations and the continued availability of technical capital. Moreover, the integration of these systems into a broader kill chain involving satellite reconnaissance and unmanned aerial vehicles indicates a move toward an information-driven warfare model. Reconnaissance satellites could provide the coarse targeting data, while AI algorithms at the battery level refine the final approach. This creates a multi-layered threat environment. The trade-off for this increased sophistication is an increased demand for highly trained technical personnel. The state must now balance the requirement for large-scale infantry with the need for a specialized, tech-savvy officer corps. Ultimately, the mass deployment of the AI-integrated 600mm system reveals an attempt to reshape the regional security environment. The state is no longer merely seeking a seat at the table through nuclear brinkmanship. It is building a conventional and tactical nuclear infrastructure designed for long-term endurance. This introduces a persistent strategic dilemma. The rapid scaling of these capabilities suggests that the window for conventional deterrence is narrowing. The cost of neutralizing such a distributed and numerous threat becomes prohibitively high. The focus on automated, mass-produced strike systems indicates an evolution toward a more proactive defense posture. In this doctrine, the ability to dictate the tempo of an engagement is seen as the primary guarantee of state survival. Whether the organizational and technical reality can fully support such an ambitious doctrine remains a central uncertainty. The balance between technological aspiration and industrial constraint continues to shift.